Good. And I'm gonna put also as group assignment, right? Group assignment. I'm gonna assign you to lab group assignment. Lab group assignment. Right in here. We'll save that as number 4. Okay, and stop. Let me do something here. I'm going to share a different screen so I have everything in front of me. Go. I presume you can see the syllabus now, right? Confirm that with me, please. Can you see the syllabus? I'm moving up and down.
Yes, we can see it.
Good, thank you. And now let's go for the other one. Here's my notes. Where did we stop? Using the table provided. Okay, so we start doing the CL. Okay, and we didn't finish doing the CL. There's one more thing here. Today is 9/6/23. That's Wednesday. Reviewing what we did, download the video. Okay, that's the okay, this thing here should be the extra credit, right? Extra credit. And we started looking at the table of confidence level. And we did some simple problems how to use that table of the confidence level, right? Let's review it. Okay, reviewing what we did for CL. We did for CL, right? 1. Uploaded CL table into Canvas. That's what we did. Confidence level, right in here. That's the CL table. Lecture and lab notes. We're going to be using this table almost forever. Then we did an example on how to use the CL table. But we did a simple example on how to use the CL table. Going back here. Right. I got this CL table. I got this example in which we had an exact value for the R-square for the determination coefficient, right? So that's what we call the critical value of R-square for this specific table. And the critical value was 9983 for n equal to 6. N equal to 6, 9983 was this one here. 9983. Oh, let's see here. N equal to 6, 99. Whatever. We can. Oh, no, wait a minute. This is an example. We did this example here. Sorry. 983715. Here you go. 983715 right here. 9.83715 for n equal to 6. And that would correspond to 1 minus 10 to minus 4 for the CL, or 99.99%. 99.99%, right? Specifically, which, by the way, is equal to 0.9999 in a fractional form. A fractional form, that's how it looks like. That's how we write it. And again, you know, the example, I'm going to write that down here. The example that we did before. Oh, not here. In this example, we use the critical value of R square, which provided us with a single value of CL, 99.99%, which is equal to 0.9999, right? And let's just summarize how to use the CL table for the last example, right? I'm going to copy this example and paste there, and I'm gonna give you the step-by-step. Here, suppose you perform an experiment and collect 6 data points, n equal to 6, and found R squared equal to 0.983715. What's the CL for this regression equation? Okay, and I'm gonna elaborate a little bit more on what we did. This is a simple example on how to use the CL table. This example is so simple. That we will not find anything like that in the classroom, in real life. Let's put not in the classroom, but in real life. Okay. However, we use this example so you can have a feeling for how the CL table should be used. Okay. And the way we do it, step by step. The step-by-step result is the following. 1. Go in the column for n and find the number of data points 6, right? Here you go. So here you go. Here's the column for n. N stands for number of data points in your graph, and that's what 6 is. Highlight. Here you go. 2. Highlight the horizontal row for n equal to 6, just like I did. I highlighted this horizontal row. 3. Find the corresponding R square value, which coincidentally, which in this case, coincide with the critical value of R square. Okay. 0.98375. Okay, so look for 0.93875, right? is right in here. Highlight this value. Coincides with the critical value of R square. Highlight this value. Highlight this value. And now we're going to concentrate on this value alone. Number n equal to 6. And here our R square coincides with the critical value in the table. The critical value in the table. To find the corresponding CL, comma, highlight the column where the R square is located. Okay, column, don't forget, there is a column and there is rows, right? Highlight, there you go, row. Highlight this cell. Let's put the cell. Okay. Let me go talk to the guy who is doing this work. Okay, I'll be back shortly. Okay, I'm back here. I talked to him. Doesn't look like he's gonna do any more noise. Because of things like that, I'm considering coming up with a soundproof room here in my place, right? So if there's any noise outside, you know, I'm in a soundproof room. But okay, so let's go ahead. I don't think it's gonna do any more noises here, but we are right in here, right? So step one, identify n equal to 6, right? The value of n, 6. Then you highlight the row where n is located, right? Then within this row, you identify the value of R squared, which is 983715. Okay, so here go to in the and find the number of data points. Okay, highlight the horizontal row where n equal to 6 is located, right? Find the corresponding R square value, which in this case coincides the critical value of R squared. Highlight the cell. To find the corresponding CL, highlight the column where the R squared is located. Here you go. That's the column I'm talking about, right? And read the value of CL within this column. That's the final step. Read the CL value within this column. In this case, 1 minus 10 to minus 4, which is equal to 99. Let's put even 0.9999 is equal to 99.99%. Okay, that's the step by step, and I'm going to raise to the power here. So think about that, chew a little bit on that, right? I need you to, we'll be using that over and over again. We use this table over and over, but that's not going to be the type of problem that you're going to see. You're going to see a more difficult type of problem. Okay, and we okay. So let's take a look at this other example, right? And we also have to go to our example, right? 9983. Yeah, that's the example that we're looking to. Okay. We have 6 data points. Do you remember this example that we were doing last time, right? So as the R squared decreases, you're going to see a graph that's with data points further and further away from this average line, right? So now let's do this. Let's do this real life problem, which is something that I'm going to see all the time. So consider this other example. Now consider a real life example, an example that we are going to see in the more frequently than the other one. This type of example that you see right in here, you don't see in your experiment. Rarely, you're gonna see it. I have seen something like that data that had an R square that coincided with the critical value only once in my whole life, and I've been teaching here since something like that since 2008, 2009. I never saw I saw an experiment like that just once. Okay, what do you mean by experiment like that just once? An experiment in which the R square coincided with the critical values of R squared that are found in my table. Each of those R squared that you see here, we call them a critical value. The critical value at 95%, the critical value at 99% for this n, right? The critical value at 99% for this other value. We don't see that in experiments, okay? What you end up seeing in the experiments are in reality numbers that are in between those critical values, okay? and even number that exceeds the critical value here on the extreme right of the table, or numbers that are less than the critical value at this extreme of the table. You can also see something like that. Okay. So let's do, instead of you doing that example, we're going to do the special cases in which you have r squared less than this critical value and r squared greater than this critical value. Okay. Let's do that. And then we come back to this one. Consider, we're going to consider, we are going to consider 3 different cases of a real life problem example that uses the CL table. Okay. 1. Okay. For the for r square lower than the leftmost r square in the table, right? Then the leftmost critical value of the r square in the table. 1. For an r square higher than the rightmost critical value of the r square should be on the table, right? On the table. On the table, and right? R square for an r square anywhere on the table. Anywhere on the table. And different and different from the critical value. Those are the 3 cases. Very simple, right? We don't have 1,000 cases. We have only 3 cases in which you have to worry about this table. That's an example of the first case, right? I'm making up those numbers, okay? N equal to 5, and then r square equal to n equal to 5, r square equal to 0.7, which is less than this critical value here. R square equal to 0.7. Okay. Find the CL. Okay. So going back to our table, right? 0.7, n equal to 5, right? R square equal to 0.7. So notice that my table ends right here, right? Ends right here. And notice also that the R square increases monotonically, right? Increases monotonically means, it doesn't oscillate. It's not like a sine function. The thing can be like an exponential function. The thing can be like a linear function and so on. They all behave in a monotonical fashion. Do you see what's happening here? 993, 999, 999, whatever, right? 0.90, 0.98 is increasing monotonically from the left to the right. And that's exactly how the critical value of the R square behaves on the extreme left of this table. The R square is going to be 0, okay? and on the extreme right of this table, you're going to have an R square equal to 1. Here is not exactly 1. Here is a number very close to 1, okay? It just happened that I didn't put enough decimal place there. But at the extreme right of this table, you're going to have exactly 1. At the extreme left of this table, you're going to have exactly 0. And the same thing applies to the CL. Notice the CL is increasing, 0.95, 0.99, 0.999, and so on, right? At the very end is going to be 1 or 100%. At the very end to the right of this table is going to be 100% or 1. Similarly, on the left side, the CL is going to be 0 at the very left.
Professor, I have a question.
Yes.
So what is that monotonic? What's the terminology?
Monotonic means that the function either decrease or increase.
Oh, okay.
Decrease or increase. That's what monotonic means. Okay. Sine functions are not monotonic because they increase and decrease, right?
Oh,
Sine
okay.
functions. Okay, that's what monotonic means.
Thank you.
So that's how this table behaves too. Okay. Both the CL and the R squared, they behave in a monotonic fashion. They increase from the left to the right. They increase from the left to the right. And the alpha that you see right in here is just 1 minus CL. Do you see here? 0.0, CL plus alpha is going to be equal to 1. Okay? 0.95 plus 0.05 is 1. 0.99 plus 0.01 is 1. So it's the complement. Alpha is the complement of CL. Sometimes it's good to leave the alpha here so you can have a better picture of the numbers for the CLR. Okay? But if I were to do the table without this alpha, I wouldn't lose any important information. The same thing applies to the degrees of freedom. Okay, the degrees of freedom. What you see here is n minus 2, right? And if n equal to 3 degrees of freedom, the degrees of freedom, df, right, is 1. N equal to 4 degrees of freedom is 2, and so on. Those are a statistical. df is a statistical parameter. Okay. So now let's continue with our example. We're recording here, right? Example of find. You're not gonna find the exact value of. I'm gonna write it down. In this case, you will not find. You cannot. Not will not. You cannot find the exact value of CL because your table, I should be putting that right here. Cannot find the exact value of CL because your table does not have a critical value for R squared equal to 0.7. Okay. In this, consequently, going back, right? Going back here. There's no, for n equal to 5 here, there's no critical value for 0.7. You have a critical value for 0.77, you have a critical value for 0.91, and so on. Okay? For this reason, okay? For this reason, not consequent, for this reason, your result will be a range of values of CL. In other words, your CL will be between two values that you can find from the table. Okay. Okay, so we go for this reason. Let's get here. Is it better if you visualize that? Let's see if I have my drawing that oh yeah, right in here. My drawing is right in here. right? I did that for you. There's one more thing, and I'm going to illustrate even more. Okay. What you have to know is that at the extreme left of this table, I don't want to do that like that. Let's see. At the extreme left of this table, the CL, right in here, the extreme left, right, is going to have a value of 0. And I'm going to put, ellipses here, right? Can you picture that? And similarly, at the extreme right of this table, I'm gonna put 1, 2, 3, right? You're going to have the number 1 here that corresponds to 100%. Can you picture that? The same thing applies to R square. The same thing applies to R square. Here you're going to have 0 at the extreme left of the table. I didn't illustrate that, but you should know that. At the other extreme right of this table, your R square is going to be 1 as well. Okay. If you're, okay, that's how you should picture the table. That's how you should picture this table here. I didn't put zeros here. I didn't put 1 here, right? Because I don't have space to do that. On this extreme left, where R squared is equal to 0, the confidence level is going to be 0 as well. Okay? That's what I have here. At the extreme right, when the R squared is equal to 1, the confidence level is going to be 1 as well, or 100%. That's what you have to know. And now we are ready. We're ready to solve this problem. We know that 0.7 lies to the left. No? Write it down. Node C. Node C that 0.7 falls between, notice the R square equal to 0.7. Notice that for this problem, R square falls between the critical, the leftmost, I'm gonna put it this way, the leftmost critical value 0. And the next critical value, what was the next critical value? 0.77148. 0.77148. That's the information that the piece of information that the table tells you. For R squared equal to 0, the CL should be 0 as well. Okay? For R squared equal to 0.77148, the CL is what? It's 0.95, right? Going back here. 0.95. Consequently, it's going to be something like that. Let's see. I'm going to illustrate in a table format so you can visualize in a different way, right? 1, 2, 3. I'm going to get that here. Maybe I should put 4 here. Yeah, let's put 4. Okay. Here is going to be N, and in the horizontal is going to be CL. Here is going to be 5, right? What my table, I'm going to write down exactly what my table doesn't tell you. here for r squared equal to 0, the CL corresponds to 0.
Wait, that's the far left critical point, right?
Yeah, that's right.
Far.
Outside the table. The far left, what do I mean far left? The far left outside the table, right?
But which one is the critical points, like
The critical value.
5, 0?
Yeah, I'm gonna wait a minute. The critical value is gonna be right here, 0.95, right? Which is
Okay.
0.77148, right? Right?
Okay.
0.77148. Yeah. That's 95. Let's make sure it's 95%. Okay, so I don't need this column. Okay, I don't need this column here. Oh, well, I need something else. Yeah, I need that column. Yes, I'm gonna do it in the following way. I'm gonna do it in the following way. I'm gonna put this one right here and right here. I'm gonna do like that. I'm gonna put my 0.7 so you can visualize it in a better way, right? CL equal to, you do not know because your table doesn't provide that to you. But my table doesn't. However, you can conclude that the CL is going to be anywhere between 0 and 0.95. Okay, and that's the type of answer that you have to provide me whenever we are doing the lab. Okay, for this case, r squared equal to 0.7 will have a CL anywhere between 0 and 0.95. Okay? And you can repeat that for any other cases. You can repeat that for n equal to 7, 8, 9, 10, right? So here you go. Do you understand how you can do that?
Little bit.
Yeah. That's that's the type of thing that the table doesn't show in there, but you have to know. Okay. And if you do another example, let's do another example of the same, And then I'm just gonna, all I have to do is to copy and paste it and just change the numbers, okay? Okay. Now consider the case of n equal to 6, right? Going back here. And I'm going to get the case that r squared is not 0.7. We did 6 right in here. Now, r squared that you got in your experiment, you get an r squared in your experiment that's equal to 0.6. Okay. And here's going to be 6. Here's going to be 0. Here's going to be 0.6. 658372. Here's going to be 0.658372. Right? 0.6. I have to change everything here. Here you go. This one. Here's the r squared equal. R squared of your experiment equal to 0, to 0.6. Here, yep. All right. Okay. I'm going to even go a next step, okay? Since 0.6 is less than 0.6583, right? And greater than 0, okay? Comma, this implies that CL, your CL is going to be between those two values. Okay. If you get the hang for it, it's become, second nature to you. But by becoming second nature, you need to work a lot on that. Repeat that over and over again until you have a better feeling. Okay. If you're going to get, let's say, number of data points 11, right? And R squared in your experiment is 0.3, then you have the same result. The CL is going to be between 95% and 0, between 0 and 95%, and so on. Okay.
But I have a question. How come the number starts from 3, not from -1?
Yeah, that's a very good question. That's a very good question. The reason for that, it has to be due to statistical value, the statistical behavior. Okay, think about that. In order for you to draw a straight line, you need at least 2 points, right? Right? You need at least 2 data points in your curve, right?
Oh, okay. So you need more than 2 data to conclude.
That's right.
Oh, okay.
Yeah. In order to get the CL, you're going to need at least 3 data points in your graph. Less than 3 data points, you cannot determine what is the CL. That's the reason. Those are the hidden reasons that no book tells you, okay? That's the reason. You cannot have n equal to 1 and find the CL. You cannot have n equal to 2 data points and find the CL. You cannot. Okay? But that's like I said, that's a very good question. Okay? That was a very good question. Now let's go for the next one. Okay, so here you go. Now we're going to go all the other way, right? Here you go. I'm going to copy and paste it. We're going to go for the other extreme of the table. Okay. We're still going to use n equal to 5. Let's see. Here you go. Example of the first case. Yeah, here you go. N equal to 5. Let's see. Okay, here you go. This one, and then we have, yeah. We're still gonna, and I'm gonna make up with one, one example here. Here is n equal to 5. Now we want a problem in which your R square is to the right, greater than what you see right here. Okay. So n is still n equal to 5. R square is equal to 0.9999. Okay. Your experimental, 1, 2, 3, 4. I need more. Okay. R square, I'm gonna write it down. R square experimental is equal. And when I mean, the R square experimental, I mean the R square that you found in your graph. Okay. I'm going to specify that R square experimental means, again, the R square that you found in your graph. Right? N equal to 6, n equal to 5. I'm gonna put boldface here so it's easier to locate the example and you don't get confused where it is located. 1, 2, 3, 4, 5, 6. Right? So here is 1, 2, 3, 4. Definitely my R square, my experimental R square is greater than this value here. So it lies somewhere here. Somewhere here in this region. Okay? Outside the range of my table. Find CL. The exact, I'm gonna emphasize, cannot find the exact value of CL because your table does not have a critical value for For this reason, your result will be in a range, of values of CL. 2 CL values that you can find from the table. 2 CL values that you can find from the table. Okay? And now going back here. falls between, not the leftmost, but now the rightmost critical value 1, right? Which corresponds to a CL of 100%, and the previous critical value of 0.1234, right? 1234, 619, 619. Okay. For R squared equal to 1, CL should be 1 as well, or 100%, which means 100% matching of which means 100% matching between the data points, the experimental data points, and the regression equation, right? For R squared equal to that, now CL is no longer 0.95, but it's going to be 1 minus 10 to minus 7. Did you see that? Yeah, here you go. 1 minus 10 to minus 7. Okay. And I'm going to raise to the power. And now I can go ahead and adapt this table for what I told you, with just one minor change. Right? 0.99 is going to be here. CL, oh, I don't need the symbol here. Straightforward, right? Once you know one extreme, you know the other extreme. Here, the CL is going to be 1 for R squared equal to 1. Right? And now what would be my CL for this one here? Right? This number is greater than this number, but is less than this number. Consequently, for an experimental R squared of equal to this value, the CL will have to be between 1 minus 10 to minus 7 and 1. You cannot find the exact value of the CL because my table doesn't have enough resolution for you to do that. Right? So for this reason, you have to report in this way. If you want to know the exact value of the CL, you have to figure out a way of, you have to find out the equation, okay, for the CL that relates in R squared, and this is not an easy equation. This is not an easy equation to work with. That's why you end up working with this table, okay? What time is that? 9:42. We can go for a few more minutes. Let me take this jacket. It's starting to get hot here. Let me turn on the air conditioning. And we can repeat the same thing for the n equal to 6, right? The only difference that the R squares are going to be to have different values. That's the only difference. I'm not going to do that. And right? And then that's the second case. Remember, second case?
So I have a question.
Yeah.
So far right is always going to be 1, right?
Yeah, in the table.
In the
far
table, so
right outside the table is going to be 1 for CL and 1 for R squared. And what would be
Oh,
the value for alpha? What would be the value for alpha on the extreme right of this table?
I don't know.
Well, think about that. Alpha is the complement of CL, right? See here, 95 plus 0.5 is 1. 0.99 plus 0.01 is 1, right? If you have 1 for the CL here, what would be the value for alpha?
I don't know.
1 plus alpha must be equal to 1, right?
1 plus, but here's the thing. The alphas are like more than 1, I think. No?
No, I was talking more than 1. See here the alpha, 0.05, 10 to minus 2, 10 to minus 3 is decreasing. See that? Alpha is decreasing. See?
Okay.
CL is increasing. And like I said, alpha is the complement of CL. What means complement of CL? CL plus alpha is equal to 1. If CL
CL plus alpha equals to 1. Okay, that's the formula.
CL plus alpha is equal to 1. If CL is 1, alpha must be what? Alpha must be 0. Okay?
Okay.
Alpha must be 0. Yeah, that's right. That's right, Norberto. That's what I mean by complement, right? I'm going to write that down here so it's easier for you to memorize, right? When we talk, we don't understand, right? It's very difficult. Here you go. Important relation between CL and alpha, right? And alpha we're going to represent, here you go. That's alpha, right? Now, the relationship is a very simple one. One is the complement of the other, and by complement of the other means that CL plus alpha must be equal to 1. So if CL equal to 1, it means that alpha is equal to 0, right? Then alpha is equal to 0, right? If CL is equal to 0, right, like the other case that we did, alpha is equal to
Then
1.
is alpha is 1? Oh, okay.
Yeah, right? It becomes easier to understand when we put that in writing, right? Okay. So never rely on learning just by listening. It's very difficult to learn when you just keep on listening and listening and listening. You have to have a picture. You have to see something, even if it is just equations. Best, of course, is to have a picture, right? Not just equations. Okay, and now we have to do the third case. Okay, we did the first and the second case. Let's go back here. R squared lower than the leftmost critical value, higher than the rightmost critical value. And then anywhere in between. And that's what this example is all about. Consider this example, n equal to 6, r squared equal to 993. Another example. Yeah, okay, here. Solution. Going back, let's see, n equal to 6, r squared 9983. Let me zoom out. 9983, right? 9983. 9983. Okay. Note that we have 9983, right? But we have 9983.67. It means that my r squared is between those two numbers. Okay. Don't report the CL. You have to report those two, right? values of CL. Okay. Okay, repeating for this specific case, and then you go. I'm going to draw the table. Becomes easier to understand, right? When we do that, here you go. I'm just so here you go. We have 10 to minus 5, 1 minus 10 to minus 5, 1 minus 10 to minus 6, right? Right in here. 1 minus 10 to minus 5. I'm going to highlight that right in here. 1 minus 10 to minus 6. 99484. 99484. 998367. 998367. And then we have 9983. I'm going to, 9983. See, this number is less than this number. And now we can write down that the CL is going to be between this value and this value and between this value. It's going to be greater than this value and less than this value. Right? That's the type of problem you're going to see most of the time in this lab. And that's the type of problem that you're going to see some of the time in this course, some of the time. And we'll also see some of, that's the type of problem you're going to see some of the time as well. This case here, right? This case. This case, and then we have this case, those 3 cases. This one is going to occur more frequently than the other 2. 950. Any questions? I want to take attendance. If you don't have any questions, I want to take attendance now and move on to our break. Okay. And roster is here. Let's see. Today is the 6th, right? Holiday. We had a holiday.
I have a question. So from the last example, you didn't include last 2 digits, right? To the problem, right? Like R square equals, it must, I mean, if you include the entire number, then it will be 0.998367, right?
0.998367. Yeah, that's right. My expression of R square is less than the critical value, right? Than R square critical value.
Okay, so like, are we going to use these tables to solve the problem, like in the future?
Yeah. In the for the lab, yes.
Oh, okay.
For the lab, yeah. Let's see here if I can put it here. I don't need to put anything like that. Critical value 1. Let's put like critical value 1, right? Critical value, experimental value. Let's put it this way. Yeah, the final answer is going to be what you see here. Yeah. Okay. In my tables, okay, what do I do? I say, let me see if I can. I write down lower CL and upper CL, okay? In my tables, in the table that I provide for the experiment. lower bound, upper bound. That would be a better way of characterizing that, those two values. That would be the lower bound for CL, the upper bound for the CL. And CL lies somewhere between those two values. Lower bound and upper bound. Once you start doing the experiment, you're gonna understand better what I mean. Okay. And let's go for my attendance, right? Camille Antonio. I don't see Camille here. Next is Tessa. Are you there, Tessa?
Yeah, I'm here.
Thank you. Chinwi? Chinwi, I don't see Chinwi. Destiny?
I'm here.
Thank you, Destiny. Gael Garcia? Thank you, Gael. Eleodoro Gastelum? I don't see Eleodoro. Next is Elisa Gonzalez. I don't see Elisa here. Next, Ridwan Harrison. Ridwan is here, right? Yeah, thank you, Ridwan. Ashley Izuma. Thank you. James Kim. I don't see James. Emily Kotko. I don't see Emily either. Norberto Lopez.
I'm here.
Thank you, Norberto. Next is Anabel Madrigal. Okay. Okay. That's it's not gonna affect, but her grade. Vanessa, are you there?
Yes, here.
Thank you. Nazmoon. I don't see Nazmoon. Oh, she was here. Okay, so yeah, let's see. I think I got her message. Yeah. Okay, I'm gonna give her half attendance. Here you go. Katrina Pacheco.
I'm here.
Okay, thank you. Okay, Camden Park.
Yeah, I'm here.
Okay. Victoria Preciado.
I'm here.
Okay. Okay. Good. Alexis Richardson.
I'm here.
Thank you. Marcos Sanchez. Good. Thank you, Marco. Eric Martinez.
I'm here.
Sure. Okay, Eric Martin. Is there anybody else that I didn't call?
I added the class late, so I don't think I'm on the roster yet.
Okay, give me your name, please. What's your name?
Carbajal Sky.
Can you please type there in the chat box so it's easier for
Yes.
me? Anybody else? Okay, Carvajal is the family name, right?
Yes.
Okay, good. So let's see. Anybody else who added late? Holiday. Good. So okay. And so let's say student asked to leave the. Oh, I'm gonna do better than that, Norberto. I'm going to upload right now what I have, okay, to the canvas. What do you think? Okay, and then at the end of the class meeting, I will update. Let's see, for here. Notes. This one. Yep, I'm gonna upload right now. And notes. Okay. Right in here. And oh man, it's Portuguese. Ay. Best.
Professor, before we take a break, I can you like explain me how to get the experimental value again? Like,
Oh yeah, we did that last time, right? Let me upload the document first.
okay.
Let me upload the document. P06 for P06 for notes. P06 notes. For 2023. Let's see if I can get that. Do you want to rename it? Oh yeah. Why doesn't work? Okay, so those four, yeah, okay, that's why. Let me erase this one here. Now I can and I replace going back. Now you have the notes for today. Let's see. Oh, it takes so long, huh? Okay, good. Let's see if we have everything right. Yeah, we have everything right here. Okay, Norberto. And going back to my lecture notes, I have to rename it. You know, I'm gonna do P06 notes for 2023. Okay, let's do this way. And we're gonna have our break 10 a.m. to 10:15 a.m. So I see you in the next 15 minutes. Stop sharing. We are back here. 10:15 a.m. Good. So I finished what I want to do for CL, for the CL case. And because today is a lab meeting, right? Let's do everything that we need to do about the lab. And Excel graphs, CL, let's put here CL, lab group assignment. And then next Monday, we start the actual material for the course. And what I want to do, I want to assign a lab group to you. lab group to you all. So the first thing, if you know anybody in the classroom, right, and want to work with them, just reach out to them and want them to be in your group, right? And want them to be in your group. Just reach out to them and exchange your information, okay? If you do not know anyone, then I will assign you a group. Okay, let's do this way. So, let's see, the 30th, let's see, I'm gonna put here lecture, and I'm going to, do I have until the very, yeah, I have. So, how do I do that? Yeah, I got the following way. Excel has some tricks here that's very nice to learn. Okay, and what I'm doing here, I'm using one of those little tricks. And this is going to be, and I'm going to create a lab sheet, right? And copy and paste here. I'll put just the labs one page. 11, 6, ok, 13, 27, 04. That's good. 15, 22nd. What I'm gonna do, I'm gonna copy and paste. Actually, I'm gonna cut and paste. Uh-oh, I cannot do that. Oh, that's not good. Yeah. Oh, haha. Yeah, he does copy, but he does not cut. Interesting. Okay. And now I have to figure out how to delete it one by one here. Okay, it doesn't cut, but he does delete. Let's see. Yeah, he does delete. The problem is cutting. Okay. Uh-oh. No, not this is YouTube. YouTube. This is YouTube. Okay. This is YouTube. Okay, start here. Okay, good. We're good. And lab. And I'm going to create a group number. Okay. Now let's start with Tessa. Tessa, do you know anyone that would you like to be in your group?
No.
No? Okay. I'll keep you in group number 1 for now. And let's see if the other group, Chinwi is not here, right? Destiny, do you know anyone in the class that you'd like to be in your group?
No, it doesn't
No?
matter.
Okay, okay, so I will assign you to Tessa's group. Is that okay?
Okay.
So go ahead, Tessa and Destiny, exchange your contact information so you can so you can contact each other. Okay. I like to put like 3 students in each group, at most 4. Okay. And let's see, Gael Garcia. Is he here? Do you know anybody here in the classroom that you would like to be in your group? No, you don't know. Okay. So let's do the following. Let's put you in group number 1, 2. Okay. So you team up with Destiny and Tessa. Okay. And Eleodoro is not here. We have only 13 students now. Looks like someone left, huh? Now, read one. Do you know anybody here in the classroom that you'd like to be in your group? I'll have Annabelle in your group. Okay, Annabelle just left, right? If I understand. Okay, so let's see. So if you may, please tell her that she's in your group. Okay. And now, Ashley, do you know anybody here in the classroom that you'd like to be in your group? No? Okay. So what we're going to do? I'll team you up with group number 2, with Ridwan. Okay, and Annabelle. Let's do that. And then you can exchange information, contact information. Norberto, do you know anybody here in the classroom that would like to be in your group?
I don't.
The answer is no?
Yeah, I don't know.
Okay, so I'm gonna put you group number 3 for now. Vanessa, do you know anybody here in the classroom that you'd like to be in your group?
No.
No? Okay. So would like to join Norberto's group?
Yeah.
Okay. So go ahead. Do you know how to contact each other? You can contact each other either by the chat, but I prefer that you use Canvas. Okay. You have the Canvas inbox that we can use to contact each other. So if you need to share contact information, just use the Canvas email. Okay, Nazmon is not here, right? Catherine, do you know, is Catherine here? I don't see Catherine. Okay, so I'm gonna put here half for Catherine. And Camden,
No.
you don't know anybody, right? So would like to
No.
join Norberto's and Vanessa's group?
Sure.
Okay, group number 3. And now we have Victoria. Preciado.
I don't know anyone.
I don't know anyone. Okay, I'm gonna put you group number 4. Alexis. Hello, Alexis.
No, I don't know anyone.
Okay, so what about you join Victoria? Let's do that. Is that okay with you?
Yeah, that's okay.
4, group number 4. And Eric. Oh no, wait a minute. Marco, right? Marco Sanchez. Marco, do you know anybody here in the classroom that you'd like to be in your group? You don't know? Okay, so what about you join group number 4? Alexis and Victoria. Okay. And now we have Eric and Sky. let's see what I'm gonna do with you. For now, is Eric? Do you know anybody here in the classroom?
No, I don't.
You don't, right? Okay, so let me put you in group number 5. And Sky, are you there?
Yeah, I don't know anybody.
Okay, so why don't you make a group with Eric, and maybe we have a few more students here that may join your group later on, okay? During the semester, maybe next class. Okay, let's do it this way. Exchange contact information with Eric, and we have 5 groups, 4 groups of 3 students, 1 group of 5. This group number 5 may be expanded later on. And I'm going to put those students who doesn't have a group, I'm going to put a 0 here. Group 0. Group 0 are those students that do not have a group. Maybe Catherine, may join your group. Okay, and Catherine. Now, what else do we need to do? So the first step, right? Okay, 1, assign students to different groups. Okay. Next, what I'm going to do, I'm going to create a folder in my Google Drive account. Google Drive account. That's a link, that you should keep it for each group. Okay, that's what we're going to do. My Google Drive account for each group, and I'm gonna give the link to this group folder, and I will provide you with the link to this group folder. So the idea here is do not share the link of this folder with anyone else outside your group. Okay, let's do that. And let's go here. Google. Someone else is coming. Oh, Catherine. Okay, good. Catherine is back. Google Drive. Okay, Google Drive, we go. Hello, Catherine. Are you there, Catherine? Hello, Catherine. Okay, I'll get back to you once. Let's see, Google Drive. This one here. This one. Good, 2023, and that's going to be my fall folder. What you see here is the spring folder. And the other one is the summer folder. So this one goes here inside. This other one goes right in here. And what we're gonna have here is physics 6 folder. Now I'm going to group 1, group number 1. Group number 2. Group number 3. Group number 4. and group number 5. Good. So I will share this link. Restricted. Anyone is the link? Let's see. General access. Okay. Commenter editor. Okay. And now I'm gonna copy. That's group 1. Group 1 is Tessa, Destiny, and Gael. Okay, let's look for Tessa here. Tessa, this is the link to your group folder. So share that, share this link. Please share this link with your group members. Don't share that with anybody else outside your group, okay? So Tessa, Destiny, and Gael must have the same link that I sent to you, okay, Tessa? I'm
Thank you.
sending the link just to Tessa herself, okay? And I want her to distribute that to you, to the other students. And Catherine, are you there?
Yes, I'm here.
Okay, good. We just select the groups, okay? And I want to put you in a group. Do you know anybody here in the classroom that would like to join forces with for the group for the lab group?
No, I don't actually.
Okay, so I'm gonna put you in the same group as Eric and Sky. Okay, here you go.
Okay, thank you.
Contact them, exchange your contact information. Okay, so group 5 now is complete, has 3 students, and he goes. Why it don't have it? Ah, interesting. Sama. Here you go. You may contact them either. I prefer that you contact them by Canvas. Okay. And now let's go for group 2. I'm gonna close this one here, don't need that. Let's go for group 2 now. Share. See, anyone with the link can access this document. And who are the students in group 2? Read one. Okay. Read one. I'm gonna send you the link. Please share this link with the other students. Oh. Huh, interesting. Okay, share. Restricted, anyone with the link, copy link. Now students of group 3. Norberto, so I'm gonna send you the link, Norberto, and then share this link with the other students in your group. Again, don't share this link with anyone else outside your group. Next is going to be Victoria, group 4. Editor. Okay, Victoria, I'm going to send you the link to your Victoria Preciado. Right in here, share this link with everybody else in your group. Okay, Victoria? Group 4, let me know. And if you don't get your link, let me know. If you don't get your group link, let me know, please. Group 5. Okay, anyone? Editor. Okay, copy the link. So Catherine, will send you the link to your group folder. Please share that with your group members. So now we're there. Okay, so in case you haven't done that before, and most likely you didn't do it because it's the first time you're taking this course with me, right? You still have access to your group folder. So let's do some simple exercises here. So we know exactly what's going on. We know exactly everything is working. Create a folder in my Google Drive account for each group. Okay. Here you go. I will provide you the link to this group folder. Do not share. Okay, we did that. Next step. Use the first you gotta tell me, if you didn't get the link, please let me know. If you did not get the link to your group folder, please let me know. If I don't hear from you, I'm going to assume that you all got the link. And I am going to sort this thing. The data, sort by name, group number. I'm going to sort by group number. Good. Those are the students, right, that are not showing up. And, group 1, group 2. I got the link. I will distribute to the other members. Okay, was the link sent through Canvas? No, I didn't send through Canvas, Norbert. I sent it through. Let's see if I sent to you. I don't think yeah, I sent to you. I just sent via chat, Zoom chat. Did you get it? The link was sent to you, Norberto, through the chat box. Did you get it? Okay, good. And now it's just a matter of sharing this link with your group members. Okay, and here you go. I'm going to highlight those students that are in the same group. Good. 3, 4, 5. We go. Good. Now it's easy to identify everybody that's in a different group, right? Let's do better than that. A little bit darker, yeah. And a little bit darker. Too dark. Okay. Okay, let me go one by one. Make sure that you all got, okay? Got link. Link. Tessa, do you get the link?
Yeah, I got it.
Okay, Destiny, do you get the link?
Yes, I got the link.
Okay, good. Next, Gael, did you get the link? Yeah, good. Next, read one you got, right? Now what about Ashley? Did you get the link, Ashley? Not yet? Oh, gosh. Okay, so not yet. Let me put here and then if it takes too long, I will send you the link. Annabelle is not here. Norberto, you have the link, right?
Yeah.
Okay, Vanessa, did you get the link?
Yeah.
Okay, next is Camden.
I have a question.
Yeah.
So the Google Drive link that you're talking about, right?
Yeah, the Google Drive link, huh?
Yeah, I got the link.
Okay, good. Next is Victoria Preciado. You got the link, right? Did I send that to you?
Yeah, I did.
Okay. Alexis, did you get the link from Victoria?
Not yet. We're exchanging emails right now.
Oh, okay. Not yet. I'll get back to you. Marcos Sanchez, did you get the link? Are you there, Marcos Sanchez? I'm gonna put a no here. Catherine got the link, right, Catherine?
Yes, I got it.
Okay, Eric, did you get the link?
No, I haven't.
Oh, you haven't? Okay.
Oh,
Sky,
sorry. Eric, I did send through Canvas. I sent it through you and Sky.
so check your email in Canvas, Eric and Sky, right? Sky, did you get the link?
Yeah.
Okay, good. So let's see. So we have one. Okay,
Yeah, I got it.
You got it? Good. So Eric got it. What about Alexis? Did you get the link, Alexis? I have Alexis and Ashley, right? The answer, I couldn't hear you, Alexis. Is that yes or no?
Yes.
Yes. Okay, good. Next, and the other one is, oh, sorry, it's here. It's Ashley who didn't get. Ashley, did you get? Hello, Ashley, did you get the link? Okay, she's group number 2. Let me send that to her. And the messaging, a message, okay. Okay. Okay, so let me help you out there. I'm gonna send the link to Ashley herself. Actually, here you go, Ashley. That's your link for group number 2. Okay, and now I wish everybody should have the links. Oh, by the way, keep this link in a safe place. Okay. Okay, keep this link in a safe place. Okay, just like you have, remember, here's a list of the links, right? That's my spreadsheet, my syllabus. Summary of links. That's the last one. 5 different links. 1, 2, 3, 4, 5. Keep it that way organized somewhere in your notes. Maybe you have a Word file there, right? And that you take notes, all that stuff. You can keep it in there. Or if you have a spreadsheet, you keep the link in the spreadsheet, whatever. Whatever place you want to keep, which, preferably in a very convenient place to access it. And now we're going to check if the links work. Right? That's the next step. Check if your link work. Okay, the first thing that you're gonna do, click in the link, and if it works, you should see your group, you should see group number X at the top of the page, right? At the top of the page. So I'm going to show you exactly what you're supposed to see. If you're group number 1, when you click the link, you should be able to see this folder, right? That's already uploaded a file in there. Okay, if you're group number 2, you should be able to see this window with group number 2 here at the top. Group number 3, same thing. Group number 3 at the top. Group number 4, okay, right? Group number 4 at the top. And finally, group number 5. Oh, here you go. Sky uploaded a file there, right? Group 5. So you should see this window here. That's the first exercise we gotta do. Then 48. The next exercise that we're going to do next, upload a file from your own computer / laptop to your group folder. Upload any file from your own computer to your group folder. Put your name on the file. Okay. Get any file. It can be a PDF file, can be a Microsoft Word file, can be Excel spreadsheet, whatever. Type your name there in the title of the file and upload it. Click and drag, right? Click, drag and drop to the folder that you have in there. We're just trying to find out whether everything is working as it's supposed to work. Can you do that? I'm going to see, here you go. I'm going to show you how to do that. Some people, right, doesn't know. I'm going to, for instance, here you go. See, I have a file right in here. I'm going to reproduce this file. I'm going to put my name in the file. I want you to do the same. Get any file there. Make sure it's not a confidential file. Make sure your file doesn't have confidential information, right? Click, drag, and drop into your folder. Okay, if you are group 1, keep the window open there of your folder. Click, drag, and drop. Yeah, and now my file is in there. I'm gonna, I'm going to delete this file. I'm gonna keep it there. Hit name, download, open. Move to trash. Here you go. I'll do the same with group number 2. Number 2. Oops. P06. Yeah. Okay. Click, drag, and drop. Right? It takes some time for it to appear there, right? That's group number 2. I'm doing exactly what I want you to do. I'm going to remove. Okay, is actually okay. Good, uploaded. Okay, redo and uploaded the file too. Anybody else? There's one more student. The other student of group 2. I presume it is. Yeah, Annabelle. Annabelle is not here. Okay, now Izumo has. Actually, Izumo has the file. Okay. Now, let's see, group 1, did you? Yeah, Destiny did it. Tessa did it as well, right, Tessa? Now I need the other student in group 1 to do the same. Group 3, let's see. Okay, group 3, click, drag and drop. I'll do that myself. Here you go. My file, Claudio, right? Click, drag and drop into your folder. Now my file, which is my critics notes, is in there. I will remove it. Group number 4. Let's see. Okay, Marco Sanchez did it. Now I need the other 2 students in group number 4 to upload a file there as well. Okay.
Professor, I have a
Yeah.
question. I cannot drag and drop the PDF file. I'm trying to do that right now, but
Really? Okay, so let's see. Do you have your folder open there? Your group
yeah,
number? Which group number are you?
3.
3. Let's see here. Physics 6, group 3. Okay, there's the. Let's see. Maybe I didn't give you. Maybe I forgot to give you. Let's see here. There's a problem.
Yeah, it's not working for me either.
It's not working for you. Okay. Yeah, it must be that I forgot to give. Yeah. Okay, that's my fault here. Here you go, editor. Now you can. Now you can do it. Okay.
Okay,
No,
thank you so much.
forgot to give a. To change. Now click, drag, and drop. Oops. Yeah. And then I'm going to delete it. Move to trash. Group 3. Group 4, let's see, only Marco Sanchez has the file in there. Let's see, group 5. Okay, who is Sky, Catherine, and Sky. What about the other students? Let's see, let me keep track who's uploading the files, right? Upload. Here you go. I'll put it 1. Insert upload file. Tessa already uploaded her file, right? Tessa?
Yeah,
Yes.
I have.
Destiny also did that, and now I need Gael to do. Okay, I'll get back to Gael. Can you hear me, Gael? Have any problems there? Let me go to read one now. Oh, you're working on it? Okay, good. Now group number 2. So read one already uploaded his file. Next is Ashley. Yeah, she did too. Okay, the student is not here today. Good. Next, group number 3. Norberto uploaded. And Vanessa uploaded. Now what about Camden? Were you able to upload it, Camden?
Yes, I have uploaded a file there.
Let me see. I don't see it there. Yeah, if you don't see your file there, I do not know why.
Oh, really?
Yeah, see? I'm sharing my screen. I see only Norberto and Vanessa.
Let me check. Let me do it one more time.
Click, drag, and drop. Okay, while you work on that, let me go to group number 4. Okay. And I will put the N here for now. Victoria is group number 4. Let's see.
I'm working on it. Sorry.
You're working on it?
I'm gonna put it there right now.
Okay, good. So
Yeah, I mean, Professor, I see it on my screen. Like group 3, Camden Park PDF, Norberto Lopez, group 3, Vanessa Mena.
Alexis, okay, let me try here. Alexis Richardson, yes, and Marco, right? Marco Sanchez, okay. Maybe let me refresh here. Nope, not yet. Let's see if I can see group number 3 there. No, I shouldn't see it. I don't know what's happening here. Do you see Norberto Varese? Do you see Eric's file there?
I can share my screen and show it to you if you don't.
Yeah, let's see. Let's see
Okay.
how I'm gonna do that. I gotta stop sharing and then go ahead.
Okay, but I need permission to do it, I think.
Yeah, I already gave you permission.
Okay. Like here.
Oh. Interesting. Why I don't see it? Yeah, that's right. Let's see. Let me. For some reason, my screen is not updated as quickly as yours. Let's see. File folder. Maybe I should close completely and go back here. Google. Google.com, Google Drive. Google Drive. Sorry, Google Drive. Okay, 2023. Oh, folder physics 6. Should be group 3. Ah, I shouldn't see it. I don't know why.
Yeah, I don't see it in our folder either, which is strange.
Ah, strange.
Yeah, I was gonna say that it's not showing.
It's not showing yours either, Vanessa?
No, it's not.
Yeah,
Ah.
it's not.
Strange. Well, we'll figure out what's going on. Okay. Let's give some time here, and then maybe it's gonna fix by itself. Let's see. Yeah, group 4, right? Let's go group 4. Good. That's Victoria. Let's see. Gail. Okay, Gail. Your group number, Gail? 1. Gail. Yeah, let's go here. Let's see, group 5. Let me go to group 5 and then I'll go to group 1. Okay, I see everybody. Oh, Sky. Okay, there is one more student that needs to upload the file, right? And this student is Eric. Eric, did you manage to upload your file, Eric?
What do you want me to drop? Just like a picture or something into the file?
It can be any file, can be even an empty file. We're just testing if you can upload the files there to the. Can be a picture, yeah. Put your name in there and upload it. Can be a PDF file. Can be a.
Yeah. I'm not sure what's going on. Let's see.
So see, I'm sharing my screen, right, Eric? Do you see that?
Yeah, I see it.
See my file, Claudio, my PDF file, Claudio. Click, drag, and drop.
Okay.
Yeah, showing up there. Right? And now I'm going to move to trash. Okay, and so okay, let's go to Gael. Let's see if I can see your file there, Gael. Yeah, I can see it. Good. Good. So yes. Anybody else? Let's see, Camden. Group number 3.
Maybe I should try different Gmail account.
Really?
Hold on. Yeah, I think because like I'm using like different school Gmail account. Okay, hold on. Let me reload.
Eric and the Eric's group. So only what 2 students that haven't been able to upload yet, right?
Okay, I got it.
You got who is that?
I got it. Group 5, Eric.
Eric, okay, group 5. Let me take a look there. Okay, good. I see it. I see that too. You know, sometimes it seems like that happens, right? In the cloud, right? And we don't know why it happens. Okay, it's 11 o'clock right now.
Professor, can you check one more time? I just uploaded
Your
it.
group number 3, right?
Yeah.
Let's see, group number 3. Oh yeah, now we have it. Camden, right?
Okay. Yeah.
Yeah, I know. So what happened? You changed the Google Drive from one school to another? Is that what you did?
Yeah, so I use different accounts to redo this. So
You mean you use different Google accounts, right?
Mhm.
Is that what you did? You use a different Google account or?
Yes. That's what
Okay,
I
good.
did.
Okay, good. Okay, 11:01 right now. Okay, the next step. Let's do this other step, and then we go for our break. Upload. You upload it, and now I want you to delete your file. Okay, one by one. Delete your file. Don't delete the other student file. Okay. And all you gotta do to delete it is let's see, where is mine? I'm gonna delete yours. Okay, Sky, here you go. Highlight, right click, and remove. Right? That's how you have to do. So each student go to their highlight their own file, right click, and remove it. Let's see how group 1 is doing. Not yet, right? Let's see, group 2. Okay, someone in group 2 already deleted his her file. Let's see who is that. Let's see, Ashley. Okay, just Tessa, right, Tessa? You managed to delete your file. Okay. No, wait a minute. Oh, it's group 2, not group 1. Okay, read one. Oh, no. Okay. Gael Garcia, let's see. Okay, nobody in group 2 has done that yet. Okay, here you go. Now we have it. Who's that? Ashley, right? Ashley removed it. What about Ridwan? Did you manage to remove your file, Ridwan? Let's see. Yeah, let's refresh. Yeah, okay. Ridwan managed to do it. And let's go back to group 1. Okay, group 1. Gael, did you manage to remove yours? Yep. Oh, everybody in group 1. Good. So 1, 2, and 3. Okay, I'm gonna put all here. And what about group 3? Group 3. That should be okay. Everybody in group 3. What about group 4? Everybody in group 4. Good. And okay, just group 5. Yes. And now let's see who managed. Eric and Catherine haven't. Eric and Catherine. Okay, still working, right? Eric and Catherine, but Sky managed to delete her file. Okay, good. Now just Catherine that needs to delete. Eric managed to delete it. What about Catherine? Okay, Catherine, okay, it's just a matter of right click, right, and remove. Okay, Catherine. And 11:05.
I
Right?
already did, Professor.
Huh?
I already did. It's just showing.
Really? Let's see. Okay, good. Okay, all you need to have fresh the screen, right? Okay, let's go for our break right now. Next, delete your file. Okay, and we're gonna have a break. 11:05 to 11:20 a.m. And I see you in 15 minutes. Stop sharing. Okay, we're back here. Let's see if we have to do anything else. The next step is just to get familiar with your Google Drive, right? One of the things that you might consider doing, create a folder. Give a title to the folder, right? And then delete it. You might need to do that during the semester. Okay? And we are not gonna do any lab today. Let me see if there's anything else that we have to talk about, okay? And otherwise, we may end it earlier today. Let's see. Lecture notes, lab notes. Let's see. Oh, gotta share my screen. Let me share my screen first. Yeah, here you go. We did that, right? How to build a table of data in Excel, how to plot, blah, blah, blah. You know, I cover all of that. CL is anywhere between 0 and 100%, should be greater or equal, right? Yeah, it looks like. Yeah, it looks like we did everything that we had to do. 11:23 right now. Let me just introduce to the first experiment. Maybe we should do that so we take advantage of this time. So that's what we did. You go, organized in groups. Oh, what before that? What we did? Learned how to obtain CL from its table. Right, we organized you into groups, created a group folder, shared the link of the group folder with the group, tested the group folder. That's what we did. We tested the group folder. Okay, and last time we learned how to plot graphs. Learned how to plot graphs. How to plot graphs. Let's see. Yeah, I will upload the notes from today. Okay. And I will also upload not just the notes, but also the video, right? We had a video from last week. I didn't upload it yet. We have a video. We're gonna have a video from today. I will upload them, both of them, today. Just keep in mind that those videos are already available from last year. So, but I will keep on uploading them as well. Okay. And we did the dimensional analysis as well. Okay, and so let's do the following. Yeah, we have half an hour to go. Let's start with one-dimensional motion. So I did everything that I wanted to do for the lab. I did everything that I wanted to do for the lab. So let us start with our lecture. Okay. What we're going to talk about is going to be one-dimensional motion. And before we talk about one-dimensional motion, let me remind you of the three 3 core concepts of physics. 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 3 basic quantities, primary definitions, and the laws of nature. We haven't seen any laws of nature yet, but we have seen the basic quantities, which, by the way, is something that we already take for granted. It's something that we learned since we were a little kid, right? Length, time, and mass. But then there are 4 more. One of them you already know is the temperature, is the idea of temperature. And we have this idea of position related to length. And we're going to see some of the laws of nature later on. What we are going to do now, we are going to concentrate on motion. That's the science of kinematics, okay? And specifically one-dimensional motion, okay? In order to come up with a one-dimensional motion, we have to know that we have to use, not to know, but to use that idea of position, the primary definition, position x, okay? The unit of length of the position is meter, and you need something else too. Not just the idea of position, but you also need, let's get that. You also need an x-axis to locate a particle, a one-dimensional axis, which is an invention, a creation in mathematics, a Cartesian axis. This is the x-axis in the units of meter. And this x-axis is supposed to be calibrated, right? It's supposed to have those measurements there. A scale, supposed to have a scale, okay? If this thing is an axis, what you see here is a scale. It's a scale of the x-axis. So we need that. A particle can be located using this axis. The position of a particle can be determined from this axis. If you have a point particle like this one here, this particle is in a position -3 meters. Okay? Now, if the same particle moves from the position of -3 meters, the same particle can move from a position of -3 meters to another different position. That's the position of 1 meter. Having said that, I'm going to introduce you another concept. Not just the primary definition, but what I call a secondary definition. The secondary definition is called the displacement. We are going to make use of this idea. Okay? See how I'm writing that down? I put primary definitions here, and then I put the secondary definition a little bit to the right. And the very definition of secondary and the definition of displacement is going to be the final position minus the initial position. You have to remember that. It's very easy to remember, right? See, notice that I put like secondary definition. Why is secondary definition? Because this definition depends on the primary definition.
Professor, so it's not xi.
Yeah, you can. Some books do xi, but some books also do that's x naught.
Oh, x naught, okay.
Yeah, some books do x naught as well. This book here, what do they do here in this book? Let's take a look there. Y plus, right? Does it use xi in the book?
I was just wondering because you said that's like an initial.
It's just a matter of it's just a matter of definition. Okay, it's not incorrect, provided you define it in such a way and tell people, right, that it means initial position. Let's take a look what's the notation of the book, right? I have here Wiley resources. Launch. Right in here, introduction to mathematics, kinematics of one dimension, displacement, right in here. Let's see what's the notation that they use here. Yeah, he used x naught. Okay, right? But he's using in vectorial notation. We're going to get to vectors later on.
Okay.
I don't like to introduce, I don't like to jump into vectors right away. I prefer to use the one-dimensional case first, and then we worry about vectors later on. But he used x naught. Okay. Okay, so for the case that I illustrated here, this case here that I illustrated here, we have this initial position and you have this final position. Okay. The delta x of this particle is going to be 1, 2, 3, 4 meters to the right. Okay, and we can even denote the displacement of the particle with a vector in an arrow, using an arrow. Okay, and here you go. This particle moved from -3 to +1. Okay, we're not going to talk about vectors yet, but I want you to understand that this displacement, this concept of the displacement, can be illustrated by an arrow that goes from the initial position to the final position. Okay, that's the, here you go. Let's repeat what I did. Right, here you go. X naught. Suppose this particle is in this position. This is at this other position, right? And then later on, it is at this other position. In this case, delta x now is going to be negative. The arrow is going to point on towards the left direction. That's why we have this negative sign right in here. Goes from the initial point to the final point. This arrow goes from the initial point to the final point. Now, if it were the other way, the arrow would point to the right. Right? And here in this case, okay, there's a mistake here. That's final position minus initial position. Two different examples. Okay, in which the particle goes from this point to the other one and goes initially from this point to the other one. Okay. Now, if at time t equal to 0, the particle is at this position 4 centimeters, and later on, let's say 7 seconds later on, the particle stays at this position 4 centimeters, the displacement is going to be 0. The displacement of the particle is going to be 0. What else do we have to know? Let's talk about the units of the displacement. The units of the displacement is the same units of position. Note, see that we are summing and we are subtracting values that have the same units, right? XF has unit of meters, X naught has unit of meter. We can do that. What we cannot do is to subtract or sum different type of units. And what's going to be the unit of delta X? Okay, it's going to be the unit of XF minus X naught, which coincides with the unit of position. That's what we're doing here. This is called dimensional analysis, right? Dimensional analysis. That's what the square bracket is all about. represented by square brackets. Like that. Now I'm going to emphasize you cannot sum or subtract quantities of different units. You cannot subtract time from position. You cannot sum time from position. And that's because they have different units. However, you can multiply or divide parameters with different units. Okay. And our situation now is the following. We have, going back, right? Definitions. Position and displacement. Next in line is going to be what I call a tertiary definition, which is called average velocity. Okay, this tertiary definition is represented by the letter V average, sub-average. But you can also see it in a different way too. Certain books represent an average velocity. Let's put here, another way to represent the average velocity is with a bar at the top of the V letter, or okay, V, let's see, V bar. Yeah, V bar, right? Like that. So either notation is acceptable. Like that. Either notation is acceptable. Mathematically speaking, V bar is equal to V average. And now we're going to do an example. Example, right? We saw the example. No. Suppose final position. We're going to look at this graph right in here. Not this one, this one here. Okay. Final position is 7. Initial position is 4. And then it takes 3 seconds. Let's say it takes 3 seconds for the object to move from initial position and the final position. Okay. Find the final velocity. Find the average velocity. Example. Initial position of a particle is 4 meters. Final position is 7 meters. It takes 3 seconds for the particle to move from one point to another, from the initial to the final position. Right? Position. What's the average velocity? That's straightforward, right? That's simple. Solution. All you have to do, I didn't define here average velocity. Let me write down the definition. Here you go. Average, okay, that's the definition of average velocity. Is delta x over delta t. Displacement over amount of time. We can here write that final position minus initial position. And by the way, in order to simplify our notation, we usually drop the f subscript, okay? And just write down as x. We do the same here for the time, final instant of time. Another simplification that we do, it's not always, but sometimes, most of the time, we can make x t naught equal to 0 seconds. It's very convenient to do something like that. And when we apply this formula to this example that you see right in here, right? Here you go. I'm going to erase that. That should be 7 meters. That should be just like a recipe, right? And 3 seconds. 7 minus 4 is 3. Right? And we end up having 1 meter per second. Like that. Notice that I did all the steps. It's a kind of straightforward step. Straightforward algebraic steps. And notice that we got a new unit here for the velocity, right? And if we do dimensional analysis without the numbers, I'm going to do that for you here. Dimensional analysis. Average velocity is delta x over delta t. The unit of average velocity is the unit of delta x over delta t, which can be written as the unit of delta x divided by the unit of delta t. And here you go. Here's the unit. The unit never has a number here. You know, if you're doing the square bracket of velocity, you never have a number here, never have a 3. The number is always 1. That's why it's a unit, right? Because it has the number 1 multiplying those letters. That's why it's called a unit. That's the average velocity. But then we have something else. Let's go ahead and copy and paste that. That's related to the average velocity. This something else is called the instantaneous velocity. And now how is the instantaneous velocity defined? Okay, just first, just think about what is exactly the instantaneous velocity. The instantaneous velocity is the value of the average velocity, taking an whenever delta t is very small or close to 0. Note that as delta t goes to 0, as delta t becomes very small, right? As delta t becomes very small, so delta x also becomes very small. Delta x also becomes very small. Okay? So it's like dividing. It is like dividing a very small number by a very small number. It's not going to be 0 necessarily. It's not going to be, the result is not going to be necessarily 0. The result is not going to be necessarily 0. It may be a finite number. It's possible. Okay? It's just like the case of, I'm going to give you an example. You know, sine of x divided by x, right? Sine of x divided by x for x equal to 0. Okay? This ratio here is not going to be 0. It's not going to be infinite, okay? You may want to write that as 0 divided by 0, okay? You may want to divide by 0. But this thing here, this ratio that you see here, is not going to be necessarily 0. It's not going to be an infinite number either. It may be a finite number, okay, which ends up being a finite number. And it's possible to do that, to see that going to using Excel, okay? When you have a situation like that, how do we write? We write, a better way of writing this ratio is by writing like that, you know, limit when x goes to 0, okay? Which, by the way, ends up being a finite number. The instantaneous velocity can be written the same way. The instantaneous velocity, we write like a regular v. Here you go. But then we write as being delta x over delta t as delta t goes to 0. As delta t goes to 0. And by the way, when delta t goes to 0, delta x also goes simultaneously to 0. Think about, try to visualize that. An object moving along the way, right? As you get the delta x of this object for every smaller delta t, the delta x tends to go to 0 as well. Okay? And I'm going to give you an example for this function here because this one is easier to visualize. Have you ever tried to do that? Try to do that in Excel. What's going to happen? Okay, here you go. I have Excel here. I'm going to open another sheet here. At this point in time, maybe at this point, you already know what's going to be that ratio of sine of x divided by x, right? I'm going to put here my x here. I'm going to write down sine of x. And I'm going to start doing the following: 10, 9, 8, okay? And then I'm going to write down sine of 10. Twice, yeah. Sine of 9. Now, wait a minute, here, like that. Sine of 8. 7. As is oscillating back and forth, okay, because this number is too large. But eventually it's going to start to converge to a given value. It looks like it's doing that right now, okay? Do you see that? These values start to converge at this very point. And now I'm going to do the following. I'm going to start to write down 0.9, 0.8, 0.7, okay? And let's see what happens. 7.1. Hey, wait a minute, yeah. And then, okay, I can do more. Right now, I'm just taking the sine and the values of sine and x, right? Okay, I don't want the 0 here. And now what I'm going to do, I'm going to divide sine of x divided by x, right? This divided by that ends up being something like that. You know, as I move along, you know, the value starts to oscillate until the value of sine of x divided by x starts to oscillate until, you know, it starts to converge towards, at this point, it starts to converge towards a value. Right? You see what's happening here? Every small step that we take, this value here of sine of x divided by x converges towards a value. If I take the sine of 0, what do I get? I get this division of 0 by 0. We don't want to do that. Excel cannot do this type of formula. So what do? We start to go make our number x as small, as close as I can to 0. You see what I'm doing here? 0.06. You know, and let's see what's happening. It start to happen. See, the sign start to go to 0. What about the ratio of the two? It start to approach the number 1. Okay. If again I do sine divided by sine of x divided by sine of x, a very small number, I'm going to put a 0 here. Okay. I again get the division by 0. It doesn't work. So what we have to do? We have to get a number that's not 0, but is close enough to 0. So you can start to have a feeling of what the value you are going to get. It's the same thing happens with delta V over delta T. Do you see this value converging towards 1 here? Okay. And here we run out of decimal places. And we put more decimal places there. Yep. It's not 1, but it's very close to 1. That's the idea of limit. That's of idea of infinitesimal limit. And that's how instantaneous velocity is defined. It's defined over a very small amount of time that reduces the delta x to a very small value as well. Okay. So any questions about that? It's 11:54 right now. I'm going to save this document as a PDF file, and I will upload it to Canvas. Okay. And I will also upload my recordings there to my channel on YouTube. And I will also provide the link for those videos in Canvas as well. Okay. So I want to stop right now. And again, do you have any questions? If you don't have it, okay, let's stop here and I will see you next Monday. Thank you for being here.
Thank you so much, Professor. Have a good day.
You too. Ok, thank you. O Rafael veio aqui?
Não.
Não? Repórter que bateu sozinho?